In this video, I'm going to talk about how do we use integral to find out the area of a surface which is generated by a function y equals to f of x. Okay, for example, look at this example here. So this is a function y equals to f of x, this function. Okay, you are doing from a to b. Okay, on this function you are basically revolving this graph, just that graph. Okay, revolving that, not the region under that. It is just, we are just revolving that graph around x-axis. If you do that, then this is the graph you will get, right? This is kind of solid, but it is empty inside, it is hollow inside. Okay, and now our goal here is to find out the surface area of the surface of this solid. You see that it is kind of cylindrical, but it is not really a cylinder, because cylinder has a constant radius everywhere, but this has a smaller radius on the left end and then bigger radius on the right end, right? It's like that. Now we want to find out the area of the surface. We know that for surface area of a cylinder with radius r, radius equals to r, and then length or height, right? Length or height equals to h is 2 pi r h. Okay, if you have a cylinder like this, okay, and then if you are trying to find out the area of the surface, this is like 2 pi r h. So h is the height of that. Okay, 2 pi r is basically the arc length of that circle on the base, basically, right? So arc, yeah, it is, you can say arc length, or the length, or we call circumference. Okay, circumference of the circle on the base is 2 pi r, and then the h is that, right? That is the total surface area of the cylinder. Now to find out the surface area of this like cylindrical shape, which is not exactly a cylinder, what we do is we cut this cylindrical shape into several discs. Okay, this is first disc I cut, this is second disc I cut, right? Third disc will look like this, fourth disc will look like this, and you see that each of this disc, if you cut this disc really thin slice type, then that disc will be a very tiny cylinder, right? You see, like very tiny cylinder, that disc will look like that, right? Very tiny cylinder. Okay, that disc will be look like that. Okay, that is a tiny cylinder. This one is one cylinder there, there is another cylinder here. Okay, and then that another cylinder may be like this. You see that? So basically what we are going to do is we will be using this formula to find out the surface area of each cylinder, and then we will be adding those cylinders, the surface area of those cylinders, to get the surface area of the whole shape, whole solid. Okay, or the surface, I would say. All right, that's the idea. Look at this. Let us take this first cylinder. Let's suppose that this is that first cylinder. What is the radius of this? That is the radius, right? Radius. So on this case, that is the radius. So the radius is basically the y coordinate. You see that? That radius is the y coordinate here. Okay, now we are going to use that concept. So y is what? Y is basically f of x, right? F of x. That's basically y. Okay, now so what we are going to do here is, look at this. For the first one, for the first cylinder, let's say that this is a1. Okay, a1 will be how much? Let us say that thickness, that means that thickness, right? Or that thickness of this tiny cylinder or tiny disc is, let's say that this is delta x1. Okay, that thickness is delta x1. So we'll have 2 pi r1 and then delta x1. R1 is the radius of the first disc or the first cylinder. Okay, what will be the a2? A2 will be 2 pi r2. That will be the second. You see that? That will be the second cylinder that we are talking about. That is the second disc or the second cylinder. Okay, and that 2 pi r2 is the radius, and then delta x2 is the thickness of that. So that is the area of that second disc, and so on. If you continue that, then if you add all these, what do you get? That will be the total area, will be the summation of n equals to 1 through 1 through whatever, how many do you want to make, okay, 1 through whatever. So if you do like so many of them, okay, so 1 through whatever, how many do you make? Let's say n, okay, and then we'll have 2 pi r I and then delta xi. But what is delta xi? Delta xi is basically that thickness, right? Delta xi is that thickness, but the thickness can be a constant thickness, or it can be, it is kind of, it can be a just like a horizontal line, or it can be some curved thickness, right? Because that thickness, the thickness may be like this, or the thickness may be like that, right? Thickness may be a curved type of thickness, right, of that disc. You see that if you look from one side, it will look like this, right? The thickness of the cylinder can be curved. In that case, the thickness will be the arc length. That length of that will be kind of arc length. You see that? So in that case, that delta xi will look like summation n equals to 1 through n. Oh, sorry, I equals to 1 through n, not n equals to. Okay, this is I. So this is I equals to 1 through n. Okay, I equals to 1 through n. 2 pi ri. Okay, so let me write down that ri will be what? Ri will be basically f of xi, right? You will get that at times f of xi is basically, ri is the radius is y, y is f of x, so it will be f of xi, which is, that radius is basically the, because you see that on the left and then on the right side of this disc the radius may be different. So what we are taking, ri is the average of those radiuses on the left and then right end, okay, on that disc. On this disc the radius may be, on the left side the radius may be one value, and the right side radius may be another value. So if you take the average of those two, that will be the radius of that disc, okay. F of xi times delta xi will be the same as we did, like 1 plus delta yi over delta xi times delta xi. That is the arc length of that, the disc surface, right? The tiny disc surface, that is the arc length, or you say the thickness. Okay guys, all right. So now if you take n tends to infinity, that means there are so many very, very thin discs. At that time, the thickest of the disc tends to 0, right? That means all the disc will have they are very thin. The thickest of the disc tend to 0. In that case, that summation will tend to integral, right? So that will be, a will be integral a to b, okay, and then 2 pi, that f of xi, okay, so 2 pi times f of xi, or I just write, let us write just f of x, okay, that's just the average of that, so that's just the random x, okay, f of x times under the root, what you do, 1 plus f prime of x square, and then times dx. That's what you do, right? So what do you get basically? So basically what you get, basically here, this is the case of when n tends to infinity, right? N tends to infinity case, okay? So this is same as, you can put 2 pi outside, okay, and then a to b, okay, and then this, again, this fxi is the radius, okay? If this this curve is rotated around y-axis, the radius will be g of y. That radius will be g of y there, okay? So that, let me write on rx instead of f of x. You can write rx. R is basically radius, but radius is f of x. Whenever you are rotating about x-axis, that rx and fx will be the same thing, okay? You can write rxi here and then rx. It is okay to write down rx is basically the radius of the disc, okay? Or basically that y coordinate there, okay? Radius of each of those discs. So, and then under the root, 1 plus f prime square and then dx. That is the final formula to find out the surface area. Okay guys, so let us do some examples. I'm going to do question number 43 from section 7.4. It says, find the area of the surface of revolution of this and then where x is between -1 and 1. And one more thing is, when you do the surface of revolution, you need to have the original curve continuous, okay? Then the surface of revolution makes sense. Otherwise it will not be a single surface. If there is a hole somewhere, it will not be a single surface, there will be more surfaces. In that case, you need to find out for each of the pieces separately, and then surface area of each of those pieces separately, and then you add them. That's what you do. Okay, all right, let us do number 43. Y is given as like that, and then a and b are -1 and +1, right? So what is y prime? Because we will need y prime here. F prime is same as y prime, right? This is same as y prime. So how would that be then? So here y prime is equal, it is like u to the, so it is like 4 minus x square to the 1/2, and then prime of that, right? You're finding the derivative of that. So it is like u to the 1/2, that is the 1/2, and then 4 minus x square is u, right, to the 1/2 minus 1 times the derivative of u is -2x, right? What do you get? You get that 2 and 2 cancel out, so you'll get -x over under the root 4 minus x square. That's what you get, because 1/2 minus 1 will be -1/2. If you move that to the denominator, it will be +1/2. +1/2 exponent is same as the root. Okay, now what we are going to do here is, what is 1? So now just plug in that into the formula, right? So what do you get? So the total area A, surface area A, is 2 pi -1 to 1 Rx. What is R? R is basically that, because we are rotating. Oh, by the way, I forgot to write where do we rotate it. Okay, it says rotating about y-axis. I need to write that one. Let me add that, about x-axis. That's what the question number 43 says. Okay, we are rotating about x-axis. Since you are rotating about x-axis, that the this is just if you draw the graph will look like this. Okay, the graph will look like, so it has like, the graph will look like, let me see, because it is like, if you square this, the equation will be x square plus y square equals to 4. That will be radius 2 circle, right? So radius 2 circle, but you are looking only between -1 and +1, so it will look like this. So the graph of that will look like that. Okay, and if you rotate it, it will look like whenever you rotate it about x-axis, it will look like this. And then you are trying to find out the surface area of this cylindrical shape. That's what you are going to do. Okay, so -1, this is -1, this is +1, -1 through 1. What will be the r? R will be basically y, right? The y coordinate of each of those points. R will be the y coordinate. So that will be basically 4 minus x square. Let me use that same color. 4 minus x square root. That is r. And then under the root, 1 plus y prime. That will be 1 plus square of that. That will be x square over 4 minus x square, and then dx. That's what you get. Okay, that's what you get. Now let us simplify that. What do you get? You basically get 2 pi and then -1 through 1 under the root 4 minus x square, right? If you simplify that under the root here, you get 4 minus x square plus x square over 4 minus x square. You see that? You try to make the same denominator, because there is 1 in the denominator of that, right? You cancel those two. What do you get? You get, by the way, there is dx, right? Dx. And then 2 pi -1 through 1, so 4 minus x square, and then what do you get here? It will be like 4 over root under 4 minus x square. That will be root under 4 over 4 minus x square. That is 2 over under the root 4 minus x square. You see that? The nice thing here is you can cancel this with that one, and then there is dx. You see that? Dx. So what is left is just 2. So 2 times 2 is 4 pi. So 4 pi and then -1 through 1 and then 1 dx. With the integral of 1, that is x, right? 4 pi and then x and then -1 through 1, because the integral of 1 is x. Now plug in 1 and -1, 4 pi and then 1 minus -1. Right? Because what do? You plug in the upper limit and then do minus and then plug in the lower limit on that x. You see that? That is that x. So you get basically 8 pi. That is the final answer. So that's how you find out the, so what is the unit of the area? It will be square unit, right? Square centimeter or square meter, square feet, or whatever unit is. So I can write square unit. For the volume you can write cube unit, square units. Okay, that's what you write. Alright, so let us do question number 45 from the book. It has y equals to cube root of x plus 2, where x is between 1 and 8, about y-axis. Okay, so you want to do this about y-axis. So if you draw the graph of this is what the graph look like. Okay, the graph will look like this. The graph will look like that. Okay, so now you are rotating about y-axis, right? So how would that look like? If you rotate about y-axis, the graph will look like this, right? And then it will look like that. You see that? That will look like that. Will be almost the graph. And you want to find out the surface area of that. Okay, this is like y equals to f of x. But since we are rotating about y-axis, so we need to solve this for y, right? We need to solve this one for y. So what do you get? You get solve this for x. Okay, y minus 2 equals to cube root of x, right? Cube root of x. So if you cube on both sides, you will get x equals to what? Y minus 2 to the cube. Also we need to find out x prime, that is dx over dy. How much you get? 3, and then y minus 2 to the square. That's what you get, right? So what is the by the way, so here the value of x is between 1 and 8, right? So what will be the value of y? Let's plug in when you do when x is equals to 1, then y is equals to what? Cube root of 1 is 1 plus 2 is 3, y equals to 3. And when x is equals to 8, then y is equals to cube root of 8 is 2, 2 plus 2 is 4. That's what you get, 4, right? Hence you get the surface area is equals to 2 pi. You need to plot the limit for y. So 3 to 4, and then r of y, okay, this is like x, okay, and then under the root 1 plus x prime square, and then dy. That's what you do. Okay guys, so that will be 2 pi, and then 3 to 4. What is r of y? R of y is basically that thing, right? That is the radius, right? Radius is basically the x coordinate. You see that? That is basically the x coordinate. X coordinate is given by y minus 2 to the cubed. Y minus 2 to the cubed, and then under the root 1 plus, what is x prime? X prime is that, square of that will be 9, right? And then y minus 2 to the 4th, and then dy. So we need to integrate that, right? Since there is y minus 2 to the 4th and there is y minus 2 to the cube, so we can use the u substitution. Okay, so you can write 1 plus 9 y minus 2 to the 4th equals to u. Then if you find the derivative, what do you get? 36, right? And then y minus 2 to the cubed dy equals to du, right? So that will be same as this, implies y minus 2 to the cubed dy will be du over 36. That's what you write, right? So now this will be like u, this will be du over 36, but we need to also find out we need to change the limit, because these limits are for y. We need to change for u. Also, when y equals to 3, what happens if y equals to 3? If y equals to 3, then you get 3 minus 2 is 1 to the here, right? 3 minus 2 is 1 to the 4 is 1, right? So 9 plus 1 is 10. So you get u equals to 10. Did you see that? U equals to 10. Now when y equals to 4 though, that will be 4 minus 2 is 2. 2 to the 4 is how much? 2 to the 4 is 16. Is that right? 2 to the 4 is 16. 16 times 9 is 144, plus 1 is 145. U equals to 145. That's what you get. Okay, therefore hence a is equals to 2 pi. Everything will be changed in terms of u. The limit will be 10 through 145, right? And then that will be you root under u, and y minus 2 to the q times dy, that will become du over 36. That's what you get. Okay, so what is the integral? You can pull that 36 out, and then you can write pi over 18, right? Because 2 pi over 36 is same as pi over 18. That will be u to the 1/2. So u to the 1/2 plus 1 is 3/2 over 3/2. So 10 through 145. Okay guys, so you can use calculator for this to plug in those values, okay, or just leave it in that format. So what do you get? This is 2/3, right? So it will be 2 pi over, so that will be, so how much is that? 18 times 3/2 is how much? So 27, right? Because 18 times 3/2 is like 18 times 3/2, so that is 9 times 3 is 27, right? So pi over 27, it will be 145 to the 3/2 minus 10 to the 3/2. That will be the final answer. Okay, so it is a little bit different when you are rotating about y-axis and x-axis, but the method is exactly the same. Only if you are rotating about the y-axis or a vertical axis, then you need to change the integral with respect to y. Okay, you need to put the limit with respect to y, your radius is in terms of y, your x prime, the square of the derivative will be in terms of y, and so on. Okay, so this is how we do find out the surface area, where the surface is obtained by revolving a continuous curve around certain straight line. Okay guys, that is the end of section 7.4. Thank you.